Hi, John McElroy here, talking all things automotive with Terry Woychowski, the president of Caresoft. And today we're going to talk body in white, in fact, Tesla's body in white and the evolution thereof.
Yeah. And again, like a lot of parts of Tesla, there's a story, an evolution story, so you can see where they're taking technology, and then we can kind of extrapolate where they may be going. Mm-hmm. But it's been a journey for them. I'll start really briefly. When we look at the 2021 Model Y, when they went from the Model 3 to the Model Y and extended it for more passenger, they started getting some mass trouble right away. And so as they put the structure back, they came up with a casting. Instead of having all these stampings and weld it all up, instead they came with a casting. And so that was the introduction in 2021.
And that's the rear casting here,
that's the rear
right?
casting there. And what they did, when they did that, they were able to get the structure they wanted at a mass reduction, but also they took 70 parts out of the body shop. So sub-assemblies, little pieces that all have to come together and get
and
welded
each
up.
of which need dies to stamp them, and then you need all the robots to weld them.
Each piece has to be engineered. Each has to be put on contract. Each piece needs to be tooled. It needs to be built. It needs dunnage. It needs to be shipped. It needs to be received. All the costs associated with every part. And so one part's better than 70. And that's what they did. And so that was really a big step forward. Shortly thereafter, 2022, we see that not only did they have the rear casting, but this is when they introduced the front casting.
And this is just like a year apart or so,
apart.
something like that. Yeah. That is amazing.
Yeah. And so now you can see this front casting. Before we get too far, John, from a safety perspective, we ask our associates to wear PPE when we're around the body in white, especially these castings. And you need to trust me on this. Some of these castings, they're sharper than a guillotine. I went up to one the other day on the Cybertruck and was just talking incidentally and just touched it. And I ended up with an industrial paper cut. I mean, it was a sled. It was like, wow.
So good.
So we wear Kevlar when we're around the body in white. And if you don't have sleeves, then we have Kevlar sleeves that we wear. But interesting, as they came forward then with the 2022, we not only saw the rear casting, but now the introduction of the front casting. And if that took 70 parts out of the body shop, this took 360 parts out of the body shop.
Wow.
So body shop's starting to get a little boring. You know, I mean, just think of the workload that's been taken out, the manufacturing floor space, all the associated costs with doing that. And
you know, just as an aside, what I love what you're talking about here, Terry, is they're designing cost out. They're not necessarily beating up their suppliers. They're not asking for price cuts. They're not decontenting the vehicle to make it cheaper. They're taking cost out through design.
Yeah, I don't know if they're doing any of that other stuff, probably a little bit of all, but the best thing to do is design it out in the first place and integrate your designs. Mm-hmm. No part should just do one single thing. And you have to look, the whole system-wide. For instance, as they did this, you'll notice also that the body in white for the 2022 Model Y, there is no floor. And it was like, whoa, you guys forgot a big piece here. And then you realize, I have this huge piece of metal, this wide, this long, and this far below it, I have another piece. Why do I have two pieces? Well, that's a body. It comes from the body group, and the body group gives you a body. It'll have a floor, guaranteed. Always has. And that's a battery. 30 kilowatt lives in there. We're not letting them out. So here's a vault, and it's safe, and go bolt them together. And I said, well, terrific. You get one. And so now one piece had to do both. So the top of the battery became the floor of the car. The top had to get a little thicker in order to do the double duty, but on net, a 14% improvement. So driving that cost out by design. Also, as you see with the casting, they're also able to take cost out because it's an enabler for a modular build. This entire module right here is the HVAC module. So the compressor, the evaporators, the octovalve, the heat pump, all these pieces, they're right there. And it just comes in and sets right there And there are 4 vertical bolts that secure it. And so because it's this front module, you can walk right up here. Operators can access everything right here, and then to continue to build the modules from the ductwork, the HVAC, right down out to the frunk and the front bumper. It all just assembles. So manufacturing cost designed out. And this we see this is the precursor to their unboxed that they announced at about a year ago at an investor conference. And you can see the steps that they're making toward that. So we saw, really a quantum jump in the castings. And of course, the whole auto industry has got their attention, and everybody's doing, they're maneuvering to see what's their answer to this. And there'll be plenty.
Yeah.
Now, when we turn to the Cybertruck, we see the castings on steroids. This is taking this technology and taking it even further. As you can see here, a front casting, it's larger. Where in this one, the front, there was a crush can here, essentially, to manage low speed type accident. And if you get into this, you just have to 2 bolts, take this piece out. The casting comes all the way to the front. You can see it's essentially corrugated, so it's designed to accordion and
to crush
and crush appropriately in a safe manner. But this comes all the way out here. Some people raise the concern, well, low speed, damageability requirements in Europe and such things. I don't think you're going to see many of these in Europe.
Yeah. Yeah.
Also, that modular approach, you can get right up to the front of dash in this design. Operators can get right here. You can see this beautiful casting here that comes in, and this, like that, it's actually the entire HVAC module
Oh
again.
my
And
gosh.
you can see in our Iceberg platform the data that we take all these things apart, and you can see how that all goes together. But it just comes in, same, sets right in here, 4 bolts. There are little tabs here. There's a fork here, goes over this tab. This moves up, just hits that. It's in place. Drive 4
So kind of
bolts.
Pokioka, just slam it in there. It's good to go.
It's just right there.
Yeah.
So this one's a V. That slides in. This comes up. Run your bolts. You're done.
That's great.
Yeah. Now it's interesting. A couple of things as we observe, because everything isn't as it might seem. There's these inserts that have had to be put in for fasteners, because this would be pretty easy to strip out. It'd be hard to build the type of torque you need. So you have the inserts that go in there, and then this is a hardened steel. So bolts can start going in and start making connections. So you'll see those used kind of extensively around. Also, it's interesting that the front motor mounts. They're bolted on.
Why is that? Why wouldn't that just be part of the casting?
Well, they were.
On
So
the
if we
Model
look
Y?
on the Model Y, they were cast right in.
Uh-huh.
And so you would ask exactly as you did. Well, we used to mold them in. How come now? And in fact, not only are they not molded in, but the fasteners have to be driven from both sides.
Oh, interesting.
Inside and out.
Because that's usually not the way Tesla does
You
it,
never
right?
want to
They
do it
like
that way.
fasteners, especially going right down vertically.
I would think that there was a desire to do this to the front stub frame, mount it there. And then there was a late minute change. I said, nah, that's not going to work. So we need to put it here. And at that point, you're so far down the road, it's like, here's your part, go bolt this up.
Yeah.
So
Got it.
that's what I would speculate as I see that here, how that looks. The casting there's tools for top and bottom, and then 2 slides that come out to make this whole piece. You can see the webbing that gives it the structure.
All the
here.
strength, right, yeah. And I'm sure all this is FEA designed, so they know exactly how wide, how thick, exactly where they go, the curvature, all
Can't
that
tell you
stuff.
how many iterations they must have gone through, but that's a engineer's dream or nightmare, one of the two. But yeah, a lot of modeling goes into this and especially with these castings, because the cooling of the part. Once the part's made, it needs to cool. It can't crack, it can't warp, can't do all kinds of bad things, got porosity. And so in the design of the tool, all that, it's all done in math. The interesting thing about this body in white, is that none of the A surface is structural.
Interesting. All the
None of
panels
it.
just hang on.
All the A surface things are just for pretty. That's it. They're just aesthetics. They don't offer any structure. In fact, they just bolt up.
Interesting.
And even in the rear quarters, bolt up just like the front fender used to.
Is
So
that for,
very
you think, repairability, or just they got so much structure in here they didn't need structure from the
I
body
think
panels?
it's part of the unboxing process to how do I drive the cost out, how do I get it so it's faster and less cost. And again, it's all in, it's a system. The fact that you get a glass roof or you don't get a vehicle, you get one, any color you want, well, it's black. You get one. Well, that means from a body shop perspective, I don't have to schedule these things in, and some have sunroofs, some have power sunroofs, some have glass.
They're all the same.
All the same, boom, and that keeps the cost down in doing that. And again, these pieces then just all come and bolt. On the side, you can see that we have hot pressed, hot stamped pieces that come together. You can see where the Taylor welded blanks come, and so you can see some witnesses where those come together, where they're welded together.
And Taylor welded, of course, is you put high strength steel exactly where you want it,
Exactly
high
where you
impact, shoulder harness, mount, strengthen. But why spend the money for that high strength steel in
Exactly.
places where you don't need it?
It's a matrix. It's where I need it, where I need it. I don't need it, where I don't need it, and I find that magic combination. In fact, if you look right here on the rocker, there's these little patches here. You see them here, 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 and here. Well, those are lining up. Remember when we looked at the battery and we saw the structure on the bottom of the battery that went cross car?
Right.
That's right where those end.
Oh.
So as this rocker comes into that, it was probably too hard. So this is a softer steel. It digs in. It says, okay, just try to push this now instead of sliding off. And you can see just the application of those. To your point earlier, if we look at where the shoulder belt or the seat belt and shoulder belt attach, okay, we have steel. This is going to take the shoulder belt loads. This is a big load. So we have aluminum piece. We're going to use steel just right where we need it.
Right, and probably high strength steel.
Yep. And then we'll do a self-piercing rivets and put that in. Also, you notice that from a casting perspective, the rear seat stanchion is now casting. In fact, a very clever casting, because the left hand and right hand, as well as the adjoining bracket front and back, they're all one part. So left and right are the same, just one on each side. This bottom bracket's the same, just one on different sides. So
Grab whatever's in the crate and put it in the vehicle,
it's,
right?
Fewer parts to handle, fewer parts to design, tool, and then of course, extra strength in the pillars and hinges. When you look here, this appears to be, you see these corner pieces that come in here. This was likely due to some barrier performance up front. Did some crash work and said, oh, I don't like how this deformed. We have too much
For
energy.
offset front impact,
Right.
probably.
So had to bring in some steel here, some metal pieces to bring in and to patch that corner up. So it isn't, Tesla's usually a measure of efficiency, right? They're very efficient in what they do, and therefore they manage the cost. Cybertruck continues a lot of those technologies, but some of them not so much. Because of different Doge cycle and different learnings, and you can see where there were other things they did because they wanted to and because they could, because of the type of vehicle it is.
But knowing Tesla, we wouldn't be surprised to see this kind of stuff get addressed so that you don't have these patches.
Well, yeah, you'd have liked to have incorporated that in the casting.
Yeah.
Just right up the front, and probably thought they did.
Right.
But the vehicle development process doesn't care. It is what it is, and if you're not getting the type of results you want, you've got to enact some kind of countermeasure to get there. But you can see how far these come. Also, if you look in the rocker, because we talked a lot about side pole, but John, if you look across, you can see this one here.
Yeah.
There is an extrusion that runs through that rocker.
Oh, yeah.
And actually attaches that module with this module. So that's how we're bringing this thing together. This whole body side ring is going to bolt up with 12 bolts. And again, I think when you look at the unbox and you try to extrapolate and where are they going with that, you can kind of see
They're on their way.
They're on their way, and there's learnings here for sure. But you can see the type of structure that's put in to, again, manage the crash, as well as to give some structural integrity to the vehicle, and to pull the front and rear modules together as one unit.
And then you got these rear castings. Holy
These
moly.
rear castings, this buttress is amazing. So again, taking these to a new level. And if you'll notice on this, John, it's giving a lot of structure right here at the C-pillar, because you don't want the pickup truck to bend right here. So by triangulating this, you bring a lot of structure from a bending and a torsion perspective. But these surfaces are actually machined off,
This right here.
both inner,
really?
inner
Machined?
and outer.
Why?
That's what places that A surface. So from a dimensional control,
It goes
it
exactly
goes-
where it's supposed to
right
be.
here, it's right where it's
Kind
supposed
of
to
like
be.
the old Pontiac Fiero mill and drill.
Exactly. And so you can see where they're utilizing that strategy to attach this whole body side.
And what are these things? They're so weird. What
Well,
is
now,
this?
this is, again, they've taken casting. Now this is a casting welded to a casting, and they attach it. So I don't know if it's afterthought or we wish we'd had or for whatever reason, but they end up with all this structure back here. So that D-pillar is bulletproof structurally. It's not connected here, but then again, all the bending wants to take place at the end of that pillar. So this is probably not that important. Plus you got the box inner. Really, from a structural perspective, you look at this casting, and this is, again, another gargantuan casting. Goes all the way up to the pillar.
Man,
And
it's
all the way back to the rear
gigantic.
boat. It's absolutely gigantic.
And again, you got this cutout so line workers can come in and
You're
start
right up
assembling
here.
things.
I'm sure that tonneau cover isn't an easy job.
Right.
Do that, but you can get right up here and you can do it. The cylinder for the air suspension mounts right here. You have that same kind of modular build happening right through here, including the box as you build out and then put in the rear structure. So
I love that approach because, everybody else, you got, line workers leaning way over to try to get stuff in, maybe scratching or denting something.
all the above. You got to wear belt buckle protection. You got ergo. How much am I reaching? How much am I bending? And how tall is the operator? I mean, it's different. So
Right.
when you can get people right up here, you can increase your operator density. Less people getting in and out because you can reach it from here. And again, your cost comes down. Your throughput can go up. The front header is, again, mixed materials. The front header is steel. So from a roof crush perspective, and they needed the strength. Back here, the header is aluminum. So by the time you're back here, life's good.
Yeah.
You can go with aluminum. You can see the castings in the flash. Remember I talked about getting industrial lacerations? I mean, these things
Yeah.
are really incredibly sharp. In areas you wouldn't think so. There's some you say, oh, that's a bad area, but there's some that are just waiting to take revenge on you.
Well, real good. There's more?
There's a little bit more, just to show you that, from the front fender here, that you have the stainless steel, which of course is the whole story of the Tesla bodies, all the stainless.
Right.
But the work's being done back here.
But the black metal's not
Steel black,
stainless.
nope.
Oh,
So it's stamped, and then it is essentially glued. There's an adhesive that
structural
holds it together.
adhesive.
Structural
puts
adhesive.
it together.
Yeah.
And I love how they've stamped in this little sort of Easter egg of the Cybertruck, and this is some sort of hammer? What do you-
I'm not sure what that is. I'm calling it Thor's hammer, but yeah, we were surprised. We pulled this. I said, "Hey, look at here. Here's a Cybertruck silhouette."
because
stamped in here.
most owners will never see that. I'll bet most people don't even know that designers love putting Easter eggs inside a car that an owner can discover over time in their
Exactly.
vehicle, right?
Exactly.
I think Jeep designers were the ones who really started that. But to put an Easter egg on the inner fender, never heard of that
Incredible.
before.
Right. When you look at the side of the Cybertruck, of course, you see this huge eyebrow that goes from the windshield all the way back. It is one piece. But the way they do it, it's sort of like what you saw there. There is an inner piece, giving a structure. The stainless is the aesthetics, and then is simply, again, an adhesive that holds it together. And then they just have clips. It's just like
just
a bird's
clips
beak
right
clip,
on.
clip, 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 clip. There.
So smart. No fasteners.
It is.
I mean, it's a fastener, but I mean not threaded or anything.
Right.
You don't need a wrench to do it.
Right. Now, you do need to learn, because I came up one day and walked up as our associates were taking it off, and there's a bend right here. I said, what? How did it get bent? Oh, there's a fastener, I didn't know it was right there, and we pull, But if you look, you kind of break its back right here structurally.
Oh,
And so right where that flange is, if you kind of gun sight this, you'll see that they take a little bit.
So notice
when
to
you go
all
service it, you better
notice to
know
all
what you're
techs,
doing.
right?
Yeah, it's everybody.
Really good.
Yep. So that's a quick flyby of the body structure. We'll be doing more work. We're doing a metallurgical analysis and what kind of material exactly, what the alloys, what grades are they using in various places. But again, taking the castings to a whole new level here.
That's great. Terry, brilliant. Thanks so much. This is fantastic
You're
insight
welcome.
to
You're welcome.
how Tesla does it.
Yeah, enjoyed it. Thanks, John. We're working hard now on the 48 volt architecture, and so as soon as we get all that, but we got to backtrace all that. There's a lot of electrical engineering to figure out what goes on when. I think with an EV, you think, well, I'm home, I shut it off, and it's just kind of going to sleep. And it doesn't just go to sleep. There's a lot going on. Conditioning of the battery, cooling it if it's hot, heating if it's cold. Any kind of over-the-air updates and checking in on itself, and if you're in a security mode, it's checking the perimeter, and it's drawing on that battery. The 48 volt architecture is drawing on that battery, so it's doing a lot of work.
Well, that's great. And when you guys get done with your analysis and all that, please have us back.
We'll have you back for sure.
Good deal.
Okay.
Okay.
Great to
Thanks
see you.
again.
Thanks, John.
All right.